Hey everybody, let's get started on our second 9 weeks test. I'm very excited to get this test done and over with and in the books so that we can move on to new math adventures in the third 9 weeks. So this video is going to take you through each problem, and I'm not going to solve each problem and give you the answer, but we will talk about each problem and I'll give you helpful hints just the way I would in the classroom. If you feel confident about how to solve the problem, feel free to fast forward through the video until you get to one that you do need some support with. Question 1. Solve the numerical expression. Show all of the steps. Remember, we've been practicing using PEMDAS pizza to help us simplify expressions. So we start with parentheses, then we move on to exponents. This problem doesn't have any exponents. Next we multiply. This problem doesn't have any multiplication. Next we divide. Next we solve addition and subtraction. Remember that multiplication and division are equally powerful in the expression, so we solve them moving from left to right in the order that they appear in the problem. Same with addition and subtraction. Solve those problems in order from left to right in the order that they appear in the problem. Question 2. Solve the numerical expression. Show all of the steps. For this problem, I would use GEMDAS rather than PEMDAS because I can see that we have two different types of grouping symbols here. We have parentheses, and then outside of the parentheses, we have brackets. The rule with grouping symbols is that you solve the innermost grouping symbols first and then move outwards. So in this case, the parentheses are inside of the brackets. So I would solve the items inside the parentheses first, followed by the items inside of the brackets. Question 3. Explain how the answers in these expressions are different. So this problem is challenging not because the math is really hard, but because it requires writing about your thinking, and I notice that some of you really do not enjoy writing about your thinking in math or in reading. So let me give you a little word bank to help you. The key difference, meaning the main difference between these two expressions, is ... You fill in the blank. Next, I'm going to give you just some vocabulary words that I would expect to see in your writing. Parentheses and order of operations are going to be critically important for you to be able to express your thinking about this problem. So I would definitely expect to see those in your sentences. The last kind of sentence starter that I'll give you is, this should be how you wrap up your thinking. The value of the first expression is ... Fill in the blank. And then tell me what the value of the second expression is. All right, so those are just some helpful hints for your writing. Remember, you should have at least 2 complete sentences for this problem. Question 4. Uncle Joey received a $550 bonus check. He spends $106 on fancy new shoes, and then he splits the rest between his 4 nieces. Write and solve an expression to determine how much money each niece gets. Now, for this problem, you're going to want to use your knowledge of the order of operations to help you write your expression. So think about what's happening in the story problem the same way you would think about a story that you read for Miss Hall or Mrs. McCluskey. Think about what happened first in the story, what happened next, and what happened last. Well, we read that what happened first is that he got his check, his bonus check, for $550. Next, he spent $106 of that money. Think about what operation you could use to show somebody spending money. Do you think that would be addition or subtraction? Last, he splits the rest between his 4 nieces. So when you think of somebody splitting money or sharing money, what operation does that sound like to you? Do you think that sharing money equally between somebody's family members, does that sound more like multiplication or division to you? So these are the questions you need to ask yourself before you write your expression. Okay, so now we're ready to actually write the expression. So you're just going to use numbers to show what happened first, what happened next, and what happened last, and use your knowledge of PEMDAS to help you do that. Meaning, can you put some of this information in parentheses to make sure that the mathematician solving the problem will simplify that part of the expression first? So put that, whatever you want the mathematician to do first, put that in parentheses. And then whatever the last part of your expression is, then you just follow the normal rules of the order of operation for that. One last helpful hint, this has to be one expression that you then solve using PEMDAS Pizza. So when I'm grading your work, I do not want to just see that you have copied down the notes that I've given you here in my video. I want to see one expression that represents the problem, and then I want to see that you have solved that expression using PEMDAS Pizza. Questions 5, 6, and 7 ask you to place a set of parentheses in the expression to make the statement true. So looking at number 5, let's just copy this down. 16 minus 2 times 5 equals 70. When you solve this expression the way it's written, using the order of operations, you would solve 2 times 5 first because multiplication comes before subtraction. And then you would subtract, and so you would end up with a value of 6 instead of 70. So what they're asking you to do is figure out where you could put those parentheses to make sure that you do indeed have a value of 70. So really you only have two choices. You can either put your parentheses here, or you can put your parentheses here. So figure out which of those two options will give you a value of 70. For number 6, if you solve this problem using the normal order of operations, you would solve 3 times 8 first, and then add 2, giving you 26, not 30. So where could you put parentheses in this expression to make sure that it equals 30? Your choices are either here or here. Which one of those options will give you a value of 30? For question 7, if you solve this expression following the order of operations, you would solve 4 times 8 first, giving you 32, then subtract 7, which would give you, I think, 25. 32 minus 2 is 30, minus 5 more. Yes, 25. So you have to figure out where you can put parentheses to force the mathematician solving the problem to solve that part of the problem first. Would you put it here, or would you put your parentheses here? Questions 8, 9, and 10 are kind of like math riddles. Or think of it as being something written in a foreign language that you have to translate into numbers. You see what I'm saying? You're going to change the words to numbers, and you're also going to use your knowledge of the order of operations to make sure that you solve it in the order that's intended by how it's written in the sentence. So here we're going to be solving twice the sum of 4 and 8. So you guys know what a sum is, right? Sum is what you get when you add two numbers together. So we're going to add 4 plus 8 together, and then it says we need to take that and double it, or take twice as many as that. Now the question is, Can we leave it like this, or do we need to add parentheses? Think about what you know about the order of operations. If we leave it alone, we would have to solve 8 times 2 first, giving us 16. So that tells me that we could probably leave it alone and not true. So that tells me that we do need to add parentheses to force the mathematician to add 4 and 8 first. Otherwise, you're not taking the sum of 4 and 8, you're just doubling 8 and then adding 4. Question 9, the quotient. Do you know what a quotient is? The quotient of 18 and 6 subtracted from 24. So we're going to take the quotient of 18 and 6 and then subtract that from 24. Write an expression that does that. 36 more than the difference of 10 and 9. So take the difference of 10 and 9 and then add 36. Notice I'm really emphasizing and then, because you're probably going to have to use parentheses to force the mathematician to deal with this first and then add. Question 11. Read the problem below and review the student's work. Identify, explain, and correct the student's error. A certain car can travel 26 3/500 miles with 1 gallon of gasoline. The gasoline tank can hold 21 5/10 gallons. How many miles can this car travel on a full tank of gas? Look carefully at this person's multiplication, shown here. We're already being told that it's incorrect. So since we know there's a mistake somewhere, your job becomes searching out the mistake. Once you've figured out what the error is, you're going to identify, meaning name what the error is, explain why it was incorrect, and then show how the person could have done the work correctly. Questions 12 and 13 give you decimal models, and they ask you to shade in the models to show either an addition or a subtraction problem. Question 12. Shade in the hundredths model to solve the addition equation below. 29 hundredths plus 53 hundredths. Question 13. Write and solve a subtraction equation to match the decimal model below. So this one is kind of like reversed because you're given the model and you're being asked to write the subtraction expression that matches it. Question 14. Christian spent $1.79 on some candy and then bought a drink for 95 cents. How much money did Christian spend? You need to write an expression, solve it, and model it on these decimal grids. In order to get full credit for this question, you must show me your work on the decimal grids in addition to writing the expression that includes the answer. Question 15. There are 245 students at Hillside Elementary School. Each of their grade levels, kindergarten through 4th grade, have the same number of students in it. How many students are in each grade level? Explain how you found your answer using numbers, words, and/or drawings and models. So what this is telling you is that however you want to show your thinking, it's perfectly okay to choose the strategy of showing your thinking that works for you. I'm not going to require a specific strategy, but you are required to find a way to show your thinking somehow. So that's why it says words, numbers, and/or drawings and models. You pick the strategy to show your thinking that makes sense to you. I always think it's helpful to draw a picture to represent the problem before you solve it, just to kind of help your brain think through the information that you're being given. So let's begin by drawing a schoolhouse and making sure that we take note of the fact that there are 245 students at this school total. This is my total. Now visualize different classrooms in the school, like kindergarten, first grade, second grade, third grade, and fourth grade. There's no fifth grade at this school. I noticed that right away, because most schools that I've been to around here go up to fifth grade, but this school says it only goes up to fourth grade. And we don't know how many kids are in each of these classes. So I'm putting a smiley face here to represent that unknown number. Your job is to think about what operation seems to match this problem when we're trying to figure out how many kids are in each of those classes. We want to know how many kids are in kindergarten, first, second, third, and fourth grade, assuming that each of those grade levels has the same number of students. Choose which operation you want to use and then write and solve your expression.